In a previous video, I gave you a short explanation for what is probability. And you might wonder, why do I really need that, all this math? Does it really help me in real-world situations? So I'm going to give you here a little puzzle. It's a very natural puzzle. It's not something contrived. And I'm going to ask you to think about how you would want to answer this puzzle. Okay? So it's called the 3-card puzzle. And what I want you to imagine is that you have 3 cards in a hat. Okay? So the cards are, one card is red on one side and blue on the other side. One card is blue on both sides. And one card is red on both sides. So I have those cards here. Let me show you. Here is the card that has red on one side, blue on the other side. This is a card that has red on both sides. And this is the card that has blue on both sides. Okay? Simple enough. So we have these cards in the hat, and we mix them. We mix the cards and do the following. We pick a card at random, okay, and we put it on the table. All right? So here we have a blue card on the table. And the color of the side that is facing up is, I call it U. It's B or R. Okay, so here is the bet that I'm suggesting we make. If the other side of the card has a different color, I will pay you $1. If the other side has the same color, you pay me $1. Okay? And I think that this is fair. Why do I think it's fair? Because suppose it's red, actually it's blue. So what can this card be? It can be either the blue on both sides or the blue and red. Okay? So there are 2 options. One is with the other side being red and one is with the other side being blue. So they both have the same probability of happening. So having a bet of 1 to 1 is a fair one. Okay? So let's see this one. Yeah, actually, I got red, so I pay you $1. So to decide what is the probability of winning $1 or losing $1, let's use a Monte Carlo simulation like we did earlier. Okay, so we're going to have a little program that generates at random an order for the cards, chooses one of the cards, and then chooses a side for the card, and then prints out the card and the outcome of whether which side wins. Okay? So here is the outcome of our Monte Carlo simulation. You can actually rerun it. So each time I'm getting slightly different outcomes. But if you look at the numbers that come out down here, it shows that different is 17 times and same is 33 times. So clearly different happens much fewer times than same. Okay, so I basically have here a game that is, even as simple as it is, it's going to, it's unfair to you, and I'm going to gain money on average from playing it. Okay, so as we saw, the simulation does not agree with the argument we made before. The argument must be false. In the simulation, the 2 sides have the same color about twice the number of times that they have different colors. So they have about twice the probability. So what does that mean? It means that you, if you play this game, you are twice as likely to lose $1 as you are to win. And because of that, on average, you are going to lose 33 cents per iteration because you lose $1 with probability 2/3, and you gain $1 with probability 1/3. So you're losing 33 cents on each iteration. So here's an alternative argument. Okay, so if we pick a card at random, then 2/3 of the time we pick a card where the 2 sides have the same color, and only 1/3 where the color is different. So that basically explains what we saw. So supposedly now we understand the game, but the problem is the original argument also sounds convincing, but it is wrong. So how can we distinguish between this argument and another argument and say which one is right without doing a simulation? Okay, a simulation is fine, but sometimes, as you saw already, running a simulation to answer a probability question is hard. You have to run for a long, long time, and you get only an approximate result. Okay, so to be sure that the argument is correct, we need more formalism. That's the point of this video. We need concepts like outcome and event, and those are things that we're going to start talking about next week.